Hi everybody, my name is Kate and welcome to a Saturday session for Junior Cycle Maths. Today we will look at the topic of sets at Junior Cycle. So this topic is for ordinary and higher level students. Any of the content that is only for higher level I will mark as we go through, but lots of the information is relevant to both levels. So to start, we'll just take a look at our learning intentions, or what you should be able to do by the end of this session. So first we need to understand the concept of a set. So basically, what is a set? Then you need to be able to list the elements of a set and organise them on a Venn diagram. So for ordinary level, we need to be able to do this with 2 sets, and for higher level, you need to be able to do it with 3 sets as well. And finally, then we need to be able to use and understand set notation. Set notation is basically the symbols we use when describing sets in maths. So I'm going to divide this session up into 4 main parts. So we'll start with defining a set, we'll ask what is a set, and we'll come up with some examples. Then we'll have a look at set notation. So we'll make an easy Venn diagram and we'll look at what the different symbols mean. Then we'll look at Venn diagrams. We'll start with one with 2 sets, then we'll move on to one with 3 sets, and then we'll look at a Venn diagram that has some algebra in it as well. And finally, then we'll look at what operations are commutative and associative when it comes to sets. So the first question you should ask yourself when studying this topic is, what actually is a set? So our mathematical definition of a set is a collection of well-defined objects. Now, what does that actually mean? So we're going to start with 2 everyday examples. So the counties of Ireland are an example of a set, as are the days of the week. Now, the days of the week, we all know they're Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay? Nobody can argue about that. Okay? Because the days of the week are very well defined. We know exactly what would be in the set of days of the week. Okay, then moving on to some number examples. So the natural numbers would be an example. So natural numbers are counting numbers. So the numbers 1, 2, 3, 4, 5 and so on. Prime numbers are numbers that only have themselves and 1 as a factor. So examples would be 2, 3, 5, 7, 11. So 11 is an example of a prime number because the only factors of 11, or the only numbers that will divide into 11, are 1 and 11. Natural numbers less than 5 would also be an example of a set. And I suppose the next obvious question then is, what is not a set? Okay, so an example of something that isn't a set would be good music. Okay, so for example, the music I consider good, you might consider not so good. Or the set of tall people. Okay, that really depends on what height you consider a tall person to be. So they're just 2 examples of things that are in sets, and we have a few examples there of sets that we will see in later examples. Being able to fill in a Venn diagram is probably one of the most important parts of this chapter. So we're going to start just by going through an easy example just to make sure we have all the basics correct. So this is a Venn diagram here on the right. We've 2 sets in this Venn diagram, and we're going to put in our sets A and B. So A and B, these are the names of our set. Okay, so we usually give sets a capital letter. So we're going to call this circle here set A, and we're going to call this circle here set B. Now the rectangular on the edge, we can call that the universal set. Okay, now when we look at set A, we can see A has the elements 1, 2, 3, 4, 5 and 6, and B has the elements 2, 4, 6 and 8. You might notice as well the curly brackets. So we always use these when we're listing the elements of our set. Sometimes people find them a little difficult to draw, just give them a bit of practice. And we always have commas between our elements as well. So when we're filling in our Venn diagram, the first thing we're going to look for is any elements that are common to both. So what's in A that's also in B? So I can see the number 2 is in both, the number 4 is in both, and the number 6 is in both. So we're going to fill these numbers into the middle. Okay, because if they're in that middle bit, they're in A, but they're also in B. Okay, and we're going to cross them off as we go along. So 2, 4, and 6. We fill those into our Venn diagram. Okay, just be careful as well. Just because they're over here, they're written twice, you don't write them twice in the Venn diagram. Okay, so every element is only put into the Venn diagram once. Okay, then we'll look at the number 1. Okay, so the number 1 in A, we're going to put it over here because it's only in A. Cross it off. Number 3 and 5 as well. Okay, and then the only element that needs to go over here in B is the number 8. Okay, and that's our Venn diagram completed. So just a few key points. Remember to be neat. Label your sets. So if they're A, B, they could be called any letter. Just make sure you label which set is which. Fill in the intersection first. That prevents you from doubling up numbers. And then cross off any elements as you fill them in. Okay, that means you won't forget any. So the next thing we need to look at is set notation. So these are basically a collection of symbols that we use when we're talking about sets in maths. So we need to know the following symbols and their meaning. So union, we're going to have a symbol for that in a second. Same with intersection, cardinal number, subset, complement, set difference, and there's also going to be one or two others. Okay, so we're going to use the last Venn diagram that we just drew there as our example to explain these terms. The first one we'll look at is union. Okay, so the symbol for union is, okay, so it's like a horseshoe, okay? Make sure you don't write it like a U, okay, so don't put a tail on it. So what union means is if we write A union B, okay, so if the question asks us for A union B, we want to know what's in A and B together. Okay, so we're going to list all the elements that are in A and B. So A union B is going to equal, when we're listing the elements, we always use a curly bracket. So it's going to be 1, 2, 3, 4, 5, 6, and 8. Okay, I'm going to count up my list to make sure I have the same amount of terms that I do in my Venn diagram. So we have how many numbers in our Venn diagram? 1, 2, 3, 4, 5, 6, 7. And here we have 1, 2, 3, 4, 5, 6, 7 elements as well. Okay, so union of A and B, or A union B, that's everything that's in A and B together. The symbol for intersection is like an upside down horseshoe. Again, make sure you don't write it like an N, okay? So just like an upside down horseshoe. So if we're asked for A intersection B, okay? A intersection B is asking what's in A and also in B. So on our Venn diagram, that's easy to spot. So it's this section here in the middle. So these are in A, but they're also in B. So our answer here, we're going to open a curly bracket. We're going to write down 2, 4, and 6. Cardinal number has the symbol of a hashtag. Okay, so if we want to know the cardinal number of set A, okay, what that means is how many elements are in set A. Okay, so if we look at set A, it has 1, 2, 3, 4, 5, 6 elements. So the cardinal number of set A is 6. Okay, we don't put the curly brackets around this because it's not actually a set, it's just a number. Okay, we could also be asked for the cardinal number of A intersection B. Okay, the cardinal number of A intersection B is 1, 2, 3, so our answer would be. The next three symbols are probably a little bit more challenging. So the first one we'll look at is subset. So the symbol for subset is kind of like a horseshoe on its side, kind of like a C. Okay, so a subset is a little part of a big set. Okay, so if I have the set, we'll just do a separate example for a second. So if I have the set 1, 2, and 3, okay, I can say that that's a subset of the natural numbers, okay, because 1, 2, and 3 are a little bit of the big set of natural numbers. Okay, so if I look at my Venn diagram here, okay, maybe the question asks, is the set 2, 4 a subset of set A? Okay, so I look at my Venn diagram and I say, okay, 2, 4, that is a subset of set A because 2, 4 is a little bit of set A. So I can say that this is true. Okay, is 8, okay, the element 8 is its own little set, a subset of A. Okay, now I can say that this is false. Okay, it's false because 8 is not in A. Okay, and finally, one more example. We'll ask, is the set 2, 4, 6, 8, is that a subset of A? Now, when I look at that first, I see that 2 is in A, 4 is in A, 6 is in A, but 8 is not in A. Okay, so 2, 4, 6, 8 is not a little bit of A because 8 is not in A. So this is false. Okay, now we just have one more symbol to go with this. So it's a horseshoe on its side if it is a subset. And if it's not a subset, draw the same symbol, but you put a line through it. Okay, so the second one there means not a subset. the symbol for set complement is a apostrophe like this. Okay, so if we write A complement, okay, that means everything that's not in A. Okay, so when we look at our Venn diagram here, you can see these are in A, these are in A. The only thing that's not in A is the number 8. So A complement, everything that's not in A is just the number 8. Okay, we could make it a little bit harder. We could have A intersection B complement. Okay, that means everything that's not in A intersection B. So the numbers 1, 3 and 5 and the number 8 is not in A intersection B. So that will be our answer. So it'll be 1, 3, 5 and 8. Okay, we could also have A union B complement. Okay, so this means we want to know what's not in A and B together. Okay, now A is here, B is here. We want to know what's not in them. Okay, that would be the bit around the edge here. Okay, now out in our universal set, there's actually nothing there. Okay, so if we want to write an empty set, we can just write 2 curly brackets close together. Okay, this is another symbol called a null set. Okay, that means an empty set. Another possible symbol for that, you can draw a circle and put a line through it like that. Okay, so A union B complement, what's not in A and B together? Okay, so it'll be this area around the edge here. Sometimes you might have a number. And our final piece of notation is going to be set difference. Okay, so the symbol for this is a sideways dash like that. Okay, so A set difference B. Okay, this means what is in A that is not in B. Okay, so what's in A without B, or what is in A that is not in B? So when I look at my diagram, these are in A, they're not in B. This is not in A, so we're not going to include that. And these, they're in A, but they're also in B. So that does not fit our question here. What is in A that's not in B? So our answer here will be the set 1, 3, 5. Okay, you could also have the opposite, B less A. Okay, so what's in B that's not in A? Our answer would be 8. To practice what we've just learned, we're going to go through this example. So we have our universal set here, which is the set of natural numbers less than 15. Now, written out in words, that's a little difficult, so we're going to put it into numbers. So we're going to say the universal set is 1, 2, okay, we'll only go up as far as 14 because it says less than 15. Then we have the set A, which is our natural numbers less than 10. Remember, natural numbers are our counting numbers. Ooh, and we won't include 10 because it says less than 10. And then B is our prime numbers less than 12. Remember, a prime number is a number that has itself and 1 as a factor only. Okay, people often make the mistake, they think 1 is a prime number. It's not. Okay, so we're going to start with 2, 3, 5, 7 and 11. Okay, now that we've that done, we can draw our Venn diagrams. Now, this question doesn't actually tell us to draw a Venn diagram, but it's going to make answering the questions a lot easier. So we'll draw a rectangle. That rectangle is going to represent our universal set. I'm going to draw our 2 sets inside then. We're going to label this as A and B. First thing we're going to look for is we're going to focus on A and B, and we're going to see what elements do they have in common. So they both have 2s, we're going to fill that into the intersection. They both have 3s, and they both have 5s and 7s. Well, it's going to tick those numbers off of our universal set, just because I've already filled them in. Then we're going to look at what's only in A. So in A we have 1, 4, 6, 8 and 9. I'm going to tick those off up here as well. And then in B, the only number we've left is 11. Now, Now, when I look up, I see that, okay, universal set, we have some numbers here that aren't accounted for yet. I need to put them somewhere, so I'm going to put them out around the edge because they're not in A or B, but they are in our universal set. So 10, 12, 13, and 14. Now we're set to answer our questions. So A intersection B, that means what's in A and B together. So there are numbers in the middle here. So 2, 3, 5, and 7. Then what's in A union B? That means what's in A and B together. So we're going to try and put these in numerical order. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 11. Okay, I'm just going to count. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in our Venn diagram, and I should have 10 here as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Okay, then the next one is A less B, or in other words, what's in A that's not in B. Okay, what's in A without B? Okay, these are our answers here. Okay, so it's 1, 4, 6, 8, 9. Next one, the cardinal number of A union B. So what is the number of elements in A and B together? Okay, so how many things are there? There are 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, don't put curly brackets there, it's just the number 10. Okay, and then the last part, A union B complement. Okay, that means all the things that are not in A and B together. Okay, so they're going to be our numbers around here. So our answer for that will be 10, 12, 13, 14. Now we're going to have a look at a word problem with two sets. Word problems are really common on the junior cycle exams. What we need to do is we need to read them and figure out how we can apply the maths we learned in our classroom to this problem. So with these, what's really helpful is to highlight the key bits of information. So 100 people, that number 100 is going to be important. We're asked whether they prefer to watch soccer or tennis. 76 said they liked soccer. 43 said they liked tennis. And 5 don't like either. Now, the question didn't ask us for a Venn diagram, but with all sets questions, the easiest way to answer them is to draw a Venn diagram. Remember, even if you got your questions wrong, you might get some attempt marks for your Venn diagram. So diagrams in every topic in maths are helpful, especially here. So we're going to have U, a universal set in the top right corner, and we're going to draw our two circles. Now, all the examples so far, we label them as A and B. Here it makes more sense. For the soccer set, we're going to label it as S, and for a tennis set, we'll label it as T. Now, I'm actually going to do this question wrong first, just to show you, okay, a very common mistake. I'm going to start with this 5, okay? That's an easy number to fill in. 5 students don't like either. Okay? Now, 76 students, who are they students, said they liked soccer. So some people might put the 76 out here, and then 43 liked tennis. Now, I just want to show you how I know that that's wrong. Okay, so in total 100 people were asked. Okay, but if I add up these numbers, they should add up to 100. Okay, but if I add up 76, 43 and 5, 76, 43 plus 5, I'm going to get 124. Okay, now we have a problem because 124 people weren't asked the question. Okay, only 100 people were. So that means my numbers down here are wrong. Now, a useful way to approach these questions is beside our letters, we know the universal set, there's going to be 100 people in total. We know in the tennis set, there needs to be 43 people in total. And in the soccer set, there needs to be 76 people in total. Okay, now those little notes are going to help me. Now I'm still going to start with this number 5, okay, because there's 5 people definitely out there. Okay, they don't like soccer or tennis, so we're not going to put them in those sets. Now, this 76 and 43. Okay, we know 76 plus 43 plus 5 needs It doesn't add to 100, it adds to 124. Now, that number should be 100, okay? That means there's 24 too many, okay? Those 24 are actually in the intersection. So they like both. So we're going to pop that 24 in the middle there. Now, the soccer circle, okay? In total, all of this circle here must add to 76. We already have 24 inside in the circle. So to get what's going to go in there, we're going to go 76 minus 24. Okay, which will give us 52. And similarly here, to get what's inside the tennis circle, we'll do 43 minus 24. And that will give us 19. Now we're going to do a quick check to make sure all our numbers in our Venn diagram add up to 100. Okay, so the numbers we're going to count are 52, 24, 19, and the 5. They should all add up to 100 because 100 people were asked the question. So we have 5 plus 52 plus 24 plus 19. I'm going to check that in my calculator. So 5, 52, 24, and 19. That equals 100. Okay? A little check like that will nearly show if you're right or wrong. Okay? If it doesn't add up, you know you've made a mistake. Okay? If you have made a mistake, it is probably with the intersection here. And a lot of people forget to subtract the intersection from the total value of that set. Now, the questions after that should be fairly straightforward once we've our Venn diagram drawn. So how many people like both sports? That's the intersection. That'll be 24. How many people liked soccer but not tennis? 52 people out here. And how many people liked soccer or tennis but not both? Okay, these people liked soccer. These people liked tennis, but they didn't like both. So we're going to add 52 plus 19. 52 plus 19 will give me 71. Okay, that's that question done. That is a little bit of a step up from the previous questions that we've been doing. Okay, so it's important to read the question carefully, mark off the important material. And what I did there the first time when I did the question and I realised my mistake, okay, that's perfectly fine. If you do that in an exam, just cross it out and try it again. Okay, sometimes finding your mistake is the easiest way to find the correct solution. Okay, always do this check with the problem solving because it really shows if you have the right answer or not. Okay, so those type of questions, we'll see more of them with the 3 sets in a minute. Okay, so just keep in mind those type of questions can come up in an exam. Go nice and slowly and just make sure that all your numbers add up to the total number. Now we're going to have a quick look at our first exam style question. Okay, so this question came from an SEC sample paper. Now, it is an ordinary level question, but I picked it because it's very relevant to ordinary level and higher level. Okay, so as we can see with this question, okay, so the first part is about sets. Okay, and then it goes on, there's a little bit of probability in it, and there's a bit of algebra involved. Okay, so what you'll notice when you start looking at the paper questions, okay, or the past paper questions, that the questions tend not to focus on just one topic. They might bring 2, maybe 3 topics into the question. So it's really important in maths that you don't just focus on one topic. You need to be able to bring in your other topics, okay? That gets easier when you've the whole course finished and you're doing loads of exam papers, but it's good to get into the practice of doing that, okay? So when you're doing a topic, make sure you're thinking, okay, what other topic might link to this, okay? Probability is very often linked to sets, okay? Probability and algebra, they probably go the best with sets. So first we're going to read the question. Okay, also remember in your exam you have the suggested time written up at the top. Really helpful. Okay, make sure if it says 10 minutes, look at the time. What some people do is they write down the time they start. So say if you start this question at 10:05, make sure you've moved on at 10:15. Okay, you can always come back to it at the end if you have extra time. So we'll read the question nice and slowly and we'll mark any important information. So Kate carried out a survey of the students in her year to see how many students studied French or German. Her results are shown in the Venn diagram before, where X is an element of N. Okay, all that means is X is a natural number. Okay, so it's 1, 2, 3, 4. It could be any number. We don't know yet. So part A, how many students studied German but not French? Okay, so these students here study German. They're not in the French circle, so your answer is 25. In total, how many students study French? Give your answer in terms of x. Now, this is important in algebra questions and across the paper. In terms of x means you need x in your answer. Okay, if it says in terms of y, you'll need a y in your answer. So studied French, it's these 68 people here and these 3x people. Now, remember x is a number. So if x was 2, in here there'd be 6 people. If x was 5, in there would be 15 people. Now, we don't know what x is. We also don't really care at this point. Okay, because we're asked for our answer in terms of x. So the people who study French, it's 68 and those 3x people. Then complete the sentence below correctly. 3x students study what? Okay, those 3x people, they're inside in the French circle and they're inside in the German circle. So they study both French and German. Now, they're a big fan of these type of questions. They want you to explain things, okay? That means explain it in your own words using the keywords in maths as well if you can, okay? So explain what the following statement means in the context of Kate's survey. So we'll have a look at it first. We know the hashtag means cardinal number. It means the number of elements. And then this is our set difference. So what this means is what's in F that's not in G, okay? Or F without G, okay? Now, it says in the context of Kate's survey. Okay, so what I've written down might get me some attempt marks, but I haven't actually answered the question because that doesn't tell me anything about Kate's survey. Okay, so what that actually means is 68 students study French, but not German. Okay, so 68 students here, they study French, but we're not including these people who study French and German, or we're not including these people that just study German. Okay, that's the first part of that question done. Now, the second part links in with probability and algebra. Now, this Saturday session isn't on probability or algebra, but we are going to do it, okay, just because we need to get used to bringing different topics into our questions. So, one student is picked at random from the 3x plus 25 students who study German. Write down the probability that this student also studies French. Give your answer as a fraction in terms of x. Okay, now we're going to think about this maybe an easier example first. Okay, so we're going to draw out a set, similar sets. And I'm going to put A here, B here, the number 10, 2 and 5. Okay, now if I say one student is picked at random from set B, what is the probability that the student is also in A? Okay, now we want to make a fraction. So a student is picked at random from set B. So the total number of people in set B is 7. That's going to go on the bottom of the fraction. Probability that that student is also in set A. We want to see, we need to use that number, so it's going to be 2 out of 7. Okay, because 2 people are also in set A. So you have a 2 out of 7 chance that if you pick a student from B, they're also going to be in A. Now, this is exactly what that question is asking. Okay, it's just with the x's sometimes people get confused. So one student is picked at random from 3x plus 25. So that's going to be our total number down here. Write down the probability that this student also studies French. So up here we have our 3x people who also study French, so we're going to put that on top. Okay, so what I often find helpful is to do these kind of easier examples. Okay, so think what would happen if they were easy numbers. Now we're just going to do the exact same thing if it's algebra. And now part F, is just a pure algebra question. So Kate finds out that there are 141 students in total in her year. She writes the following equation in x, work out the value of x. Now we're just going to do that. We're going to solve for x. So we have 68 plus 3x plus 25 plus x is equal to 141. Now, a good method for this is to mark off your like terms. So 68 and 25, they're just both normal numbers. We'll be able to add those together. And we have 3x and x. So 68 plus 25, we're going to add that. That's going to give me 93. And then we have 3x plus 1x will give me 4x is equal to 141. Okay, now, when it says work out for the value for x, we want x is equal to a number. That means we want x on its own. Okay, now I have two problems here. Okay, so I've got this 4 in front of the x, and I've also got this 93. Okay, I'm going to call them my two problems. I don't want them to be there. Now, the first thing I'm going to get rid of is the 93. So to get rid of a positive 93, we're going to subtract 93 from the other side. So it'll be 93. Sorry, we're going to get rid of that. So it's going to be 4x is equal to 141 minus 93. So 4x is equal to 48. Okay, now I'm really close to my answer. We want x is equal to a number, but unfortunately we have 4x is equal to a number. So we need to get rid of this 4. To get rid of that 4, you're going to divide both sides by 4. So you'll be left with x is equal to 48 divided by 4. So x is equal to 12. Okay, now again, this is an ordinary level question, but I would really recommend higher level students go through this and make sure you can understand it, because the difference between higher level and ordinary level, at higher level you'd need to form this equation yourself. Okay, and then you would have to go on and solve it yourself as well. Okay, so at ordinary level here, they gave it to you, you just have to solve it. At higher level, you would need to form this equation yourself, okay, from the Venn diagram. Okay, so that's kind of the difference between ordinary level and higher level with sets. And we will do a higher level one in a minute where we do have to form that equation. Okay, but overall, I think that's a really good exam question to do because it brings in lots of topics. Okay, also, you have 10 minutes to do it. Okay, I don't think you'd be overly pushed with time there. Make sure you read the question carefully and get it done in the 10 minutes. If you don't get it all done, move on and come back. So this is our first question with 3 sets. Okay, now it's not much more difficult. We're going to do exactly the same thing. So we're going to write down our sets with our lists of numbers, we're going to draw our Venn diagram, and then we're going to answer our questions. Okay, so the way this is written out is different. Okay, earlier we saw that we had a set A that was the natural numbers less than 10 or something like that. Okay, this is basically the same thing, it's just another way of writing it down. What this means, so A is the set of elements x such that x is a prime number less than 10. So x is a prime number less than 10, which means A is 2, 3, 5, 7. Okay, remember, be very careful, 1 is not a prime number. Okay, then B has the elements x such that x is an even natural number less than 10. So that'll be 2, 4, 6, 8. We're not going to include 10 because it says less than 10. And C is an odd natural number less than 10. So 1, 3, 5, 7, 9. Okay, and then we have our universal set. Okay, and what this means is that x has to be bigger than 0 and less than 10. Okay, and it's also a natural number. So our natural number is bigger than 0 and less than 10. Our universal set is going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, be careful. This symbol here is less than 10. If it was less than or equal to 10, then you would include the number 10. That's not relevant to this question. We have it less than 10. Now we're going to draw out our Venn diagram. Okay, with the 3 sets, make it nice and big. We're going to have our universal set up in the corner. We're going to have our 3 circles. Okay, and we'll label them as A, B, and C. Now the first thing we'll look for, is there anything in all of them? So is there anything that's in A, B, and C? Now, we're looking here at these three sets, and no, there isn't anything. Okay, now we're going to look at what is in common between A and B. So we'll look at these. Okay, A and B, they both have 2. Okay, so A-B intersection is here. Okay, we're not going to include this bit here because that is also in C, so we're just working here. So we said 2 was in common of A and B. We're going to cross it off our list. Okay, now we'll look at B and C. We'll look at these two. What's in common there? Okay, nothing. So we can't put in anything. And now we'll look at A and C together. So for A and C, they have a 3 in common. So we're going to put that in our intersection of A and C down here. They also have a 5. And they also have a 7. Okay, so 3, 5, 7 are ticked off from our universal set 2. Now, we're going to look at the things that are only in A. Okay, so nothing only in A. In B, we have the numbers 4, 6, 8. And in C, we'll have 1 and 9. Okay, we have everything ticked off of our universal set as well, so we have nothing out here in the empty space. Now, we'll answer our questions. So the first one here, A intersection B intersection C. So what they're talking about here is this section, the intersection of all 3 sets. There's actually nothing in there. So if you remember from earlier, we had our symbol for our null set, which looks like that. Okay, you could also write that they mean the same thing. Next question, A intersection C. So we're going to look at all of this area here. Okay, now what's inside in there is 3, 5, 7. Okay, the next section asks for the cardinal number of A. So how many elements are in A? There's 1, 2, 3, 4. Again, don't put that in curly brackets. Section D is looking for A union B complement. So A union B is going to be all of this highlighted area here. Okay, that's all A union B. And the complement means everything that's not in A union B. What's not in that section? It's 1 and 9. So that's our answer to that. So A union B complement is 1 and 9. Now, next question says name an empty set in the Venn diagram. Now, there's loads of them. So in there is empty. That's A intersection B intersection C. Here is empty as well. Okay, what's that? That's A without B union C. Okay, kind of a tricky one to name, but it's A without B union C. Okay, and then the last section is the cardinal number of A without B complement. Now, when they combine the set notation, they can become a little bit tricky. So what we're going to mark in, A less B. Okay, so what's in A that's not in B? Okay, these bits here are in A, but they're not in B. Now, A without B complement, okay? So what we're actually going to count is everything except that area. So we're going to count all these orange numbers that I'm highlighting. Okay, we're looking for the cardinal number, so we're looking for the number of those. There's 1, 2, 3, 4, 5, 6 of those. Okay, be careful with these questions. Sometimes highlighting things, kind of marking things off helps. So first I found A less B. Okay, A less B, or what's in A that's not in B, was the yellow section. And we want the complement of that, so we want everything but that, and the cardinal number, count them up. Okay, so that's our first example with 3 sets. We'll see another one now in a second that you can give a go on your own first. Might be a good idea to practice it. So this is another Venn diagram question or set question with 3 sets. It's fairly straightforward, but what I'd recommend you do is pause the video, attempt the question, and then click play on the video to check your solutions. So in this question, we have 3 sets, A, B, and C. They've listed them out for us, and they've even drawn the Venn diagram. So all we need to do is fill it in. You always start with these in the very middle. Okay, so at the middle intersection, what's common to A, B, and C? So when I look at my sets here, I can see that the number 5 is common to all 3 sets. So I'm going to cross it off and I'm going to put it right there in the middle. Now I'm going to look at what's in common between A and B. That'll go in that section there. So A and B, you can see they both have a 2. And they both have a 3. Now I'm going to look at A and C together, and they'll go in there. So A and C both have a 1. And I'm going to look at B and C for this section. B and C is, what do they have in common? They both have a 4 in common. Once you have the intersection done, you have the hard bit done, all you need to do now is fill in the rest. So 6 and 7 are just in A, so they'll go out there. 8 and 9 are just in B, and 10 is just in C. Okay, that's our Venn diagram completed. Now we'll look at the questions. So part B says list the elements of each of the following sets. So the first one it asks for is A union B. Okay, A union B is everything that's in A and B together. So we're going to go this one and all of those. Okay, so I'm going to list them in numerical order. Order doesn't necessarily matter, but it's certainly nice for the person who's correcting it if it's in order, and it just looks better overall. Okay, so in A and B we have the numbers 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, remember to use your curly brackets when you're listing elements of a set and a comma in between each one. The next part then is A less C, or in other words, what's in A that's not in C. Okay, so we're going to include all of these elements in A, but we're not going to include 1 and 5 because they're also in C. Okay, so our answer there would be 2, 3, 6, 7. Okay, now the final part, A union B intersection C. So we want everything that's in A, which is all this yellow section here, and we also want everything that's in B intersection C, which is, we're going to add on that bit there. Okay, so our elements then in A union B intersection C is 1, 2, 3, 4, 5, 6, and 7. Okay, that was a very straightforward question with 3 sets. Just be careful, make sure you have no elements written twice. If you do have an element written twice, it's probably because you got the intersections wrong. So start with the intersections and then just read your questions carefully and know your symbols, and that question should be fine. Now we're coming on to what is probably the most challenging aspect of this topic. Okay, so this is a higher level question. It brings in Venn diagrams with 3 sets. It's a word problem and it also has some algebra involved in it. Okay, bit of a step up from the questions we have been doing. We're going to use the exact same methods and then hopefully we won't hit any problems. So we're going to take out a highlighter and we're going to read the question nice and slowly, highlighting the key pieces of information. So a group of 100 junior cycle students. Okay, that number 100 is important because at the end our total needs to add up to that. We're asked if they intended to study art, biology or chemistry at senior cycle. 24 students opted for art only. 40 students opted for biology. Now you'll notice the difference in phrasing there. There's a difference between opting for art only and opting for biology. Those 40 students that opted for biology, some of them may also have opted for chemistry as well. Okay, so we need to be careful of the phrasing. 50 students opted for chemistry, 14 students opted for art and biology but not chemistry, 18 students for art and chemistry but not biology, 8 students for biology and chemistry but not art, and then 4 students did not opt for any of these. Let X represent the number of students who opted for all 3 subjects, construct a Venn diagram and solve for X. Okay, first thing we're going to draw our Venn diagram. We'll make this nice and big because there's going to be lots of information to put in it. Okay, up in the right hand corner we'll have our universal set, and we know that that should equal 100. Okay, so at the end all our numbers should add up to 100. We'll draw our 3 circles. We're going to call this circle A for art, B for biology and C for chemistry. Now we always start right here in the middle, and they tell us in the last line, let X represent the number of students who opted for all 3 subjects. So we're going to put our X in here. Now there's a few more bits of information we can put in. Okay, so 4 students did not opt for any of these subjects, So I'm going to tick this off, and I'm going to put those 4 out here. Okay, they don't fit in any of those sets, but we still need to include them in our universal set. Okay, now, where would we go next? So 24 students opted for art only. Okay, so they're going to go out here in this section, okay, because they only did art. 40 students opted for biology. Now, they opted for biology, they could have also opted for art or chemistry. So we're going to put a 40 out here just beside the biology to know later on that this whole circle here needs to add up to 40. Okay, so I've used this piece of information, and also same thing down here, the 50 people opted for chemistry. Now, I don't know what number is going to go here or here yet. We'll come back to that in a second. 14 students opted for art and biology, but not chemistry. So art and biology is this section here. They didn't opt for chemistry, so we can fill that number straight in. It's 14. So I have this piece of information used. 18 students opted for art and chemistry. So art and chemistry, but not biology. So the 18 is going to go in here. And then 8 students opted for biology and chemistry, but not art. Biology and chemistry, but not art. And there's 8 of them. They're going to go in there. Now, we have 2 empty spaces here and here. So I'm going to go out here and I'm going to do some rough work. So we know in total, this whole circle, okay, so all of this biology circle here needs to add up to 40. So far we have 14 and 18, okay, and x. Okay, now that is not our answer, okay? We cannot just write 40 into that diagram. So what we need to do is we need to do 40 minus 14 minus 8 minus x. Okay, 40 minus 14 minus 8 minus x. 40 minus 14 minus 8, you can put that into your calculator. That's going to give you 18, and we still have our minus x. So that's the amount of people out here who just did biology. And here we're going to do something very similar for the chemistry. Should all add up to 50. So 50 minus 18 minus 8 minus x. That's going to give me 24 minus x. Okay, these bits off to the side are just our rough work. There's no harm in including a little bit of rough work. Okay, now that's our Venn diagram filled in. So the next part of our question then, we need to solve for x. Now, we need to go right back up to the top. So they told us that 100 people were asked in total. So that means that all of these numbers here should add up to 100. Okay, so when I add all of these numbers, don't forget about the 4 out in the universal set, they should all add up to 100. So I'm going to write them all down. So I'm going to add up 24 plus 18 plus 24 minus x plus 14 plus 8 plus 18 minus x plus 4. They should all add up to 100, so we're going to let it equal to 100. Okay, now just be careful when you're doing those. Be no harm to kind of cross those off as you're going along, just to make sure you've included them all. Now, this is a purely algebra question after this. So what I would do is I'd take out my highlighter and I just mark off all the bits that I can add together. So I'm marking off all the normal numbers. Okay, so all the numbers without any x's involved. When I get out my calculator, I'm going to add those up. 24 plus 18 plus 24 plus 14 plus 8 plus 18 plus 4. 1 second, sorry, I'm going to do that again. 24 plus 18 plus 24 plus 14 plus 8 plus 18 plus 4. I get out 110. Now I'm going to look at my x's. So my x's here, minus x plus x minus x. So minus x plus x will actually cancel each other out. Okay, so that'll just cancel. And then we're still left with a minus x. And all of that is equal to 100. Okay, now a few ways to do this from here. What I would do, I would say in my head, okay, I have 100. 100 minus what? 110 minus what is equal to 100. So 110 minus what is equal to 100. 110 minus 10 is equal to 110 minus 10 is equal to 100. So then x must equal to 10. Okay, so this is my final answer along with my Venn diagram. So what I would do, I would try that question again by myself just to make sure that you understand especially these numbers out here. That was the most challenging part, okay? And if you're rusty on the algebra, just make sure you keep revising your algebra, okay? Because you can see how important it is. It comes in. Now this is the final exam style question we're going to do. It's similar, again, it's a word problem with algebra involved in it and 3 sets, okay? So you can see up at the top there, the suggested maximum time is 15 minutes. So again, what I'd recommend you do, pause the video, give it a go, make sure you don't go over the 15 minutes, and then when you're finished, come back to the video and press play and we'll explain it. So each of the students in 6th year in a particular school has WhatsApp, Instagram or Snapchat. The number who have each app are as follows. So 36 students have WhatsApp. Now that doesn't mean they only have WhatsApp, they may also have Instagram and Snapchat. 40 students have Instagram and 54 students have Snapchat. 14 students have WhatsApp and Instagram. Now again, that doesn't mean they only have WhatsApp and Instagram, they may also have Snapchat. Okay, if it was only WhatsApp and Instagram, it would say 14 students have WhatsApp and Instagram only. 24 students have Instagram and Snapchat, and X students have WhatsApp and Snapchat but not Instagram. 8 students have all 3 apps. Use this information to complete the Venn diagram below. So, first thing we're going to fill in, as always, is our intersection. So 8 students have all 3 apps, nice and easy to fill in there. Now we're going to fill in our X as well. So 8 students have WhatsApp and Snapchat but not Instagram. So those X students are going to go in there. Now I'm going to fill in just my whole numbers here. So I know the whole WhatsApp circle should add up to 36 because there's 36 people that have WhatsApp. Also, Instagram should add up to 40 and Snapchat should add up to 54. Okay, now these numbers aren't in my set. They're more there to remind me than anything else that that whole circle should add up to those numbers. Okay, 14 students have WhatsApp and Instagram. Now, we want to fill in this section up here. Now, 14 students have WhatsApp and Instagram. Okay, but they also may have Snapchat. So really what needs to go into this section here is 14 minus 8 because we already have 8 people counted here. Okay, so 14 minus 8 will give me 6. Okay, so 14 students have WhatsApp and Instagram. This is the WhatsApp and Instagram intersection, and now we have 14 in there. Okay, so this piece of information used, and 24 students have Instagram and Snapchat. So this whole section here needs to add up to 24. We already have 8, so we need to put a 16 in there. 24 minus 8. Okay, we also have this used. Okay, now we're going to fill in the people who only have Instagram, only have WhatsApp, and only have Snapchat. Now we're going to do the Instagram circle first because there's no X involved. Okay, so this whole circle needs to add up to 40. I already have 6, 8, and 16. So I already have, 6 plus 8 plus 16 is 30 people. Okay, 30 people are already accounted for, which means there must be only 10 people out here because 40 minus 30 is 10. So 10 people only have Instagram. Do a quick check. 10 plus 6 plus 8 plus 16 is equal to 40. So I'm correct with that circle. Now we'll move down over to WhatsApp. So all of this circle here, it should add up to 36. We already have 6 plus 8 plus X people accounted for. Okay, so to find out what actually goes in here, we're going to do 36 minus 6 minus 8 minus X. So 36 minus 6 minus 8 will leave me with 22, and we still have our minus X there. And similarly for the 54 here, we're going to do 54 minus 16 minus 8 minus X. That will give me 30 minus X. Okay, so just be very careful. Writing these numbers on the outside really helps. Okay, now the next part, you can see how similar this question is to the last one. There are 80 students in total in 6th year. Find the value of X. So we're going to just highlight the numbers we're going to add in. So it's going to be 22 minus X, X, 30 minus X, 8, 6, 16 and 10. Okay, so we're going to add all those numbers and we're going to let it equal to 80. So we have 22 minus X plus 30 minus X plus 8 plus 6 plus 10 plus 16, and that will all equal 80. Okay, now again, our little bit of algebra here. So we're going to highlight all the numbers that we can add together. Okay, when I add all of those up, I should get 92. And now we're going to look at our x's. Okay, for the x's then, minus x plus x, they're going to cancel each other out. And we have another minus x there. So overall there we just have 92 minus x is equal to 80. And again, could go down the algebra route, subtracting 92 from both sides. But this is quite simple algebra, so we're just going to do it quite logically. Okay, so 92 minus what is equal to 80? 92 minus 12 is equal to 80. So then x must equal 12. That's our answer there. Okay, so part A and B there, Venn diagram with a little bit of algebra. Now part C then is all about our notation. So it's really important that we know our notation well. So the table below shows 4 statements. Each statement is written in mathematical notation and in English. Complete the table. So here we have our maths notation that we want us to write in English. Now people sometimes find this difficult, okay? It doesn't have to be very fancy English. Just make sure it's linked to the question. Okay, so we can see the examples here. They're using the keywords from the question. We're going to do the same. So 8 is equal to, we know the hashtag is equal to, means the cardinal number of W intersection I intersection S. Okay, so I'm going to look at my Venn diagram. WhatsApp intersection Instagram intersection Snapchat. Okay, that's this number here in the middle, and it's equal to 8. Okay, so what this means is the number of people of students with Instagram, Snapchat, Instagram, Snapchat, plus WhatsApp is 8. Okay, so that's what that maths sentence, I guess, means in English. Now, second time now we need to, for statement 2, we need to do the opposite. So they give us the English, we need to write in maths. So 24 students have Instagram and Snapchat. So we're going to kind of use up what they did up here as our model. So we're going to let 24 equal to the cardinal number. They have Instagram and Snapchat. Okay, so that's the intersection. So I intersection S. So 24 is the cardinal number of Instagram and Snapchat. Then statement 3, we're back to our maths language. 10 is the cardinal number of Instagram without WhatsApp and Snapchat. Okay, so 10 here. So 10 students have Instagram but don't have WhatsApp or, I'm going to struggle to put this in here, I'll write down here, Snapchat. Okay, what's useful with this question as well, okay, so if I look the number 10, the number 10 is only out here. Okay, so from the set you might be able to understand it better than the set notation or the mathematical notation. So out here, these people, they're only in WhatsApp, they're not overlapping with any other set. Or only in Instagram, sorry. Okay, and then statement 4, more students have Snapchat than have WhatsApp. So the number of students with Snapchat is the cardinal number of S. The number of students with WhatsApp is the cardinal number of W. Now, more than or less than, we use these type of symbols. Okay? With these, the easiest way to remember it is that the crocodile always eats the bigger number. So if you think of this like a crocodile's mouth, it's going to be open towards the bigger number. So more students have Snapchat than WhatsApp, so the bigger number is Snapchat. So we're going to have our inequality sign like that. Okay, so that's quite a challenging question. It brings in a difficult Venn diagram, a bit of algebra, and then a lot about set notation. So if you could do that, really well done. If you can understand this, that is probably your chapter of sets mastered. So our last section, or the last thing we need to look at, is just the words commutative and associative. So commutative basically means if you swap the order, it will stay the same. Okay, so addition is an example of a commutative property. So if you think about 1 plus 2, that's equal to 3. It's the same as 2 plus 1. Okay, so swapping the order doesn't make a difference. Now, for sets, we need to look at intersection, union, and set difference. So the first question we're going to ask there, is A intersection B the same as B intersection A? So we're just going to look at these sets that we were using earlier on. So A intersection B is this section here. Okay? But that's the same as B intersection A. So we conclude that yes, intersection is commutative. The next one now we'll look at is B intersection A. Or sorry, A union B and B union A. So A union B is all of this section here. I guess we're going to include all of A, and then we're going to include all of B as well. Okay, so A union B, okay, B union A, they're the same thing. So that's also true. Now, the final thing we need to look at is set difference. Now, this is the one that's going to cause a bit of difficulty. The first thing we're going to do is we're going to look at A less B. So what's in A that's not in B? It's these here. So they're in A, but they're not in B. Is that the same as what's in B, but not in A? So over here, 8 is in B, but it's not in A. So that's what's in B, but not in A. Are they the same thing? No. So we can say that set difference is not a commutative property. Okay, so set difference is not commutative. It doesn't work if you swap the order, but intersection and union do. So the associative property then basically asks, if you move the brackets, does your answer stay the same? Okay, so we're going to start with union. Okay, so when we look at this, okay, the brackets, remember from BIMDAS, you always do what's inside in the brackets first. So B union C. B union C is all of this section here, and it's all of this section here as well. Okay, that's B union C. And then the second part says we must union that with A. So we're also going to include everything out here. Okay, so basically there, that is the whole Venn diagram. Now, we'll look at the other half. If we change the brackets, will it make a difference? So first here, we're going to do A union B. It's going to be all of this section here and all of B. And then we're going to union that with C. So it'll be all this section down here. Okay, again, we've shaded in all the Venn diagram. So we can say, yes, A, or union is an associative property. Okay, now for set difference. The first thing we're going to do is we're going to do what's inside in the brackets. So this is going to tell us to do A without B. So what's in A that's not in B? Okay, all right, we'll do that again. What's in A that's not in B is all this section here. Okay, now we also don't want anything that is in C. So the second part then says without C. What we're going to do is we will get rid of some of our shading, so we can't include this section in C. So that is our answer for the left-hand side. Now, remember that. I'm going to rub out the highlighting, but remember what section we coloured in. Okay, so it was only the bits in A only. Okay, none of the intersecting bits were included. Now, we'll try the right-hand side. So we'll try this bit over here. Okay, so first we're going to do B without C. So what's in B? That is not in C. That's all this section here. All of these things are in B, but they're not in C. Okay, and now we want B without C. What we want now is we want A without this section. Okay, so we want everything that's in A that's not in this section. Okay, so we're actually going to end up colouring in this section here. Okay, so this new kind of pinky orangey section that I'm colouring in, that's what's in A without everything that's in the yellow section. Okay, now we can see they were different sections. So the section that I'm actually talking about now is all of this, but with this intersection as well. Okay, whereas the last time we were just out here in only A. Okay, so we can say that set difference is not an associative property. If you move the brackets, it does change. Now, we're nearly finished. Just the last thing that I want to leave you with is just some useful tips. So when it's a set question, even if it does not ask you to do it, make sure you draw a Venn diagram, because the questions are always easier to answer when you have a Venn diagram drawn. Okay, know your symbols. Okay, they may not tell you what they mean in the exam, so they may just say A intersection B with the symbol. You need to know that means intersection. Read the questions carefully when problem solving, okay? take out a highlighter, highlight off the key bits, okay, the key points in the question. Always start with the intersection, okay, whether it's for a Venn diagram with 2 sets or 3 sets, always start with the intersection. Then check your answer makes sense. Now, this kind of comes into all areas of maths, but if the question was about 100 students and you found that the number of students with their favourite colour being blue and green is 220, okay, that doesn't make sense, okay, so that comes into all parts of maths, but always just make sure your answer makes logical sense in the real world, okay. And finally, be prepared to link in other topics. So algebra and probability are 2 very common ones linked in with sets questions, okay. With all your topics, you need to be ready to link in questions, different topics, but for sets in particular, algebra and probability are important. So I hope you found this video useful. I wish you the best of luck in your study of sets, and come back to this video if you have any issues. Make sure to try all the questions, and if you can do all these questions, I would say you have a pretty good understanding of the topic.